Chapter 8, Probability. What are my chances? Learning outcome for Lecture 1 are: at the end of the lesson, students should be able to define the concept of experiments, outcomes, events, sample spaces, and random selection. State the basic laws of probability. Find the probability of an event. Probability is the chance of an event occurring. Let's say, what is the probability of choosing a black pen from these 4 pens? So we only have one pen, one black pen, and the total pen we have here together all are 4. So we have only 1 out of 4. So that's why the probability is equal to 1/4. Definition: experiment is an action that leads to one of several possible outcomes. Outcome and observation all results from the experiment. For example, so for the experiment we have record the grades of an examination. So the outcome, it will be A, B, C, D, F. So we have grade A, grade B, grade C, grade D, and fail F. Tossing a coin. So for a coin we have 2 outcomes, which is the head or tail. And rolling a die. So for a die we have 4 surfaces, means 4, not 4 but 6 surfaces, means that we have 6 outcomes, which is 1, 2, 3, 4, 5, and 6. Sample space S, a list of all possible outcomes of an experiment, illustrated by using Venn diagram, tree diagram, or set notation. So this one you have learned in high school, so we just have to recall back. Event, a collection of outcomes of or a subset of the sample space. Example 1. 2 coins are tossed. So what are the outcomes? Okay, so the outcome is that if we toss 2 coins, so maybe the 2 coins both get head. So that's why we have H, both are head. And then it may be coin 1 is head, coin 2 is tail. Or coin 1 is tail, coin 2 is head. That's why we have HT or TH. And the next outcome is if we get both are tail. So the number of sample space, which is all the possible outcomes, are 4. Let Y getting at least 1 head. So Y is an event. The event where we getting at least 1 head. So we either get 1 head or 2 head. So for 1 head from the sample space we have HT and TH. But for head, so we have 1 outcome. So what is the probability? So the number of event Y is equal to 3. So the probability will be 3 out of 4. Definition of probability. Probability is a measurement of whether a particular event will or will not occur in any random experiment. A probability is a number between 0 to 1. So it cannot be negative number and it cannot be more than 1. So if we look at the scales, so we have 0 as the impossible outcome for the event to happen, and 1 as the certain that the event will be happen, or events if it's a probability of 0.5. 0.25 we can call it as unlikely, and 0.75 above will be likely. In general, the probability of an event A occurring is denoted by probability of A, where the number of possible outcomes divided by the total number of outcomes. So the number of possible outcomes for that event A. So PA, probability of A, is equal to the number of A divided by the number of sample space. Probability of sample space should be equal to 1 because N divided by N. For example, and the probability of A, an event, it should be in between 1 to 1 inclusively. Example 2. 1 ball is taken from a bag containing 3 red and 2 blue balls. What is the probability of getting a red ball? So because we have 3 balls of red, and then the total ball is equal to 5. So we have n red, the number of red is 3, and blue, number of blue is 2, and the number of sample space, the total balls in the bag is 5. So the probability of getting red is n red divided by n sample space, which is 3 over 5 or 0.6. Example 3. Find the probability of obtaining a number greater than 4 on a single toss of a die. Okay, so what are the outcomes of a die? So we will get either 1 or 2 or 3 or 4 or 5 or 6. So the number of sample space we will have for tossing a die is 6. And then the number of the event A means that the number more than 4, it's only 5 and 6. That's why the number of event A is equal to 2. So the probability of getting number greater than 4 is equal to NA divided by NS, which is 2 over 6, equal to 1 over 3. Venn diagram, tree diagram, and contingency tables. Sometimes relationships between events can get complicated. Tools like Venn diagram or tree diagram or contingency table may be used to visualize the problem of the probability. Venn diagram. It shows the relationships between different groups of outcome of one event, including the union, intersection, and complement events clearly. Contingency tables show the observed frequency for two variables in various categories. Tree diagram, each branch assign the probability of the event. Solve conditional probability and also multiply probability along the branches and vertically. So this is the example of Venn diagram. Let's say in the sample space we have two events A and B. So what we will have is A intersect with B, or A together union with B, or the complement of A and B. Okay, let's do some example. In a certain group of 100 students, 54 studied calculus, 69 studied physics, and 35 studied both. If one of these students is selected at random, find the probability that the student took calculus or physics. The student did not take any of the two subjects, or the student took physics but not calculus. So how can we represent all of these events? Let's say F is the event that represent the student selected studied physics, and C for studied calculus. So in Venn diagram we have two circle representing F and C. So there is an event where they are taking both of the subjects, which is 35 from the question. And then it is said that the student that studied F, which is the physics, is equal to 69 students. Is it true? Let's check back. Yes, 69 study physics. It's including the person that studied physics and calculus. So because we know both studied both 35 students, and study physics is 69 including the both, that's why we have to subtract 69 with the 35. So we have 34 for study physics only, and 54 studied calculus, means that for the studied calculus only is 54 minus 35. So we have 19% that taking the calculus only. So this is our event. So for the person studied physics and calculus is 35. The student studied physics is 69. So for this area, it is for the student that studied physics only. So we have to subtract 35 from 69. That's why we get 34. And this area is the area for the student that study calculus only. That's why we have to subtract 35 from 54. So we have 19 per student that studied calculus only. And then what are the remaining students who not taking any subject? We know the total student here is 100. So the remaining area outside of those both circles are 100 minus all of this. So 34 plus 35 is 69. 69 plus 19 is 88. So the remaining should be 12% who do not take any subject. Okay, so now To answer the questions, referring to the Venn diagram, the person that studies calculus or physics. So it's either they can take physics only, they can take calculus only, or they can take both. So we have to add up everything inside the circle. So 35 plus 34 plus 19 divided by the total sample space, which is 100. So we have the answer is equal to what? Total up everything, it's 88 over 100. So simplify, divide by 4. So we have 22 over 25. And then for question B, neither F nor C, means that they are not taking both subjects. So it should be outside all the circles. So it should be 12 over 100, which is equal to, so divide by 2. So we have 6 over 50 and divide by 2 again. So we have 3 over 25. Okay. And then for the next question, question C, probability that it study physics but not calculus. So which one study physics but not calculus? It must be in this area only, so not include the one that studied calculus. So it should be 34% only, divided by 100. Example 5. A coin is tossed twice. Find the probability of getting at least one head. So this one we have discussed earlier. We have the outcome of head, and then the second toss is head also, or the first is head and then the second one is tail, or the first toss is tail, the second toss is head, or the first tail, the second toss is tail. So each probability is 0.5. So we want to find the probability of getting at least one head. So which one has the result of at least one head? So it's either 2 heads or 1 head. So out of these 4, the answer should be, at least one head is equal to probability of head, tail, and tail, head. So what is the probability of head? It will be multiplication along the branches, which is 0.5 multiplied by 0.5. And for head, tail is 0.5 multiplied by 0.5. For tail, head also is 0.5 multiplied by 0.5. So total up everything, we get 0.75. Why 0.75? It's 3 out of 4 outcomes. Okay. Example 6. A survey is conducted on a group of workers comprising production operators, administrative officers, and security guards. The survey is to determine the total working hours in a week. So for example, if there is the workers that work less than 40 hours, or maybe in between 50 to 70, or the other one should be more than 70 hours. So for this contingency table, it is said that 63 workers are working in the production operator area and less than 40 hours. So one of the workers in the survey is randomly selected. Based on the information provided, calculate the probability that the workers being a production operator. So what are the total production operator? So the total production operator from each of this group is 196. So what are the total workers? So we need to find the total out of this. So just add up here. So what do we get here? It's 0 plus 4, 3, 7 and 270. We can check going down here. So 8, 0 and then 10, 7, 2, 0. So the total workers here is 270. So the workers being a production operator will be 196 divided by 270. So simplify the answer, we get 98 over 135. The next question is the workers who work between 50 to 70 hours. So what the total of those workers working between 50 to 70 hours is 70 workers. So for the probability, it should be 70 divided by 270. Okay, so simplified for this one. So we have 7 over 27. So this one is 196 over 270. So simplified for this one. So we have 98 divided by 135. And then the workers being an administrative officer and working greater than 70 hours. So which one is administrative officer? The B one. And then which one is working more than 70 hours? This one. So the overlap between these two categories is 8. So the probability should be what? It should be 8 out of 270. So divide by 2 or 4. Can we divide by 4? No, 2 is 4 over 135. And then the workers being a security guard working less than 40 hours. So which one is security guard? This one. And then working less than 40 hours is this one. So the intercept is 4. 4 out of 270. So it's 2 over 135. So let's check the work together. So for question B, it should be 7 over 27. Yes. Administrative officer that working more than 70 hours is 8 over 270, which is 4 over 135. Security working less than 40 hours is 4 over 270. So the answer is 2 over 135. Complementary event. The complement of event A called not A is the event that event A does not occur. So it will be complement of event A lah, written as A prime or A bar. So let's say this is an event A inside the circle. So event A complement is outside the circle. We represent it as A prime. So this event A together with A prime, the total probability will be 1. Okay, because it will be complete the sample space. So if we rearrange, probability of A prime is equal to 1 minus probability of A, and probability of A is equal to 1 minus probability of A prime. So Venn diagram. So the dark blue circle is A happens. For this one, A does not happen. So outside of the circle A will be dark. And then for this one, is the intersect between A and B. So A intersect B. So A and B happen simultaneously. Both A and B happen. And this one, only A happens. So A intersect with not B. So A happens but B does not happen. Only A. And this one is the union between A and B. So A happens or B happens or both happen. At least one happen. And this one is A prime intersect with B prime, or both and A and B do not happen. Neither A nor B happen. And this one is A intersect B prime union with A prime intersect B. So only one happen. Either A or B happen. Okay, so it's not include the intersection part. Only one happen. So it's either A only or B only. So this area is A intersect with B prime. So A dan bukan B. It must not include B. That's why it's A intersect B prime. This one A prime intersect B. And in the middle is A intersect B. So together both is A union B, and outside of the both circle is A union B bar. It should be bar outside of this. So we have bar. So A union B bar, complement of the union A union B, or A prime intersect with B prime. Given the Venn diagram below, find probability of B, probability of B prime, probability of A prime not intersect with B, probability of A intersect B prime union with A prime intersect with B. So PB, where is the PB? Probability of PB. So everything inside the circle B is 8 plus 7. So what is the total probability? What is the total sample space? So total everything we have 12, 8, 7. So 15, 27, it's 100. So NS is equal to 100. And N of B is equal to 15. That's why our probability is 8 plus 7 divided by 100. So 15 over 100 equal to 3 over 20. Probability of not B. So we can either using the rule of complement, or you can total up everything that is outside the circle B. So if it's outside of the circle B, it's 12 plus 73 divided by 100. So 85 over 100 equal to 17 over 20. Or by using the complement, it's equal to probability of B prime is equal to 1 minus probability of B, which is equal to 1 minus 3 over 20, which is equal to 17 over 20. Probability of A prime intersect with B. So it must be only B. So the one with A got prime, right? So we don't want to include A, so it should be B only. So which area is B only? The crescent moon. So the 7 only is the B only. So it will be 7 over 100. And then for this one, A intersect with B prime, so the crescent moon in the A and union with A prime intersect B, crescent moon in B. So the union means that we just total up both events. So 12 plus 7 divided by 100. So 19 over 100. Thank you for the lecture 1.